Well, good morning. Actually, I have a little bit of good news in here. I was just talking to Sue and said, boy, most of the stuff, regardless of where I look, where I read, there's not a whole lot of good news on the energy or the worldwide front, whether it's food, whether it's energy, whether it's climate. It's really easy to get depressed these days. But anyway, in here I do have some small items of good news. So we'll go ahead and start. Before I talk about where we're at, I'll answer the question, how do we get here? As some of you probably know, the energy funds at this campus have been managed at the system level for something better than 30 years. Back about that long ago, they pulled the budgets in from the campuses with the idea that there would be an advantage to aggregating the energy budgets, and therefore one could, for example, bargain for larger scale contracts such as natural gas. And in fact, about 20 years ago, the U of I did that. They brought in that pipeline that came from Monticello, you may recall, brought it in down by Church Street, and that contract also, NGPL also services gas or provides gas to the Chicago campus. So they were in fact able to aggregate some large scale pricing. The bad news is that it was managed as an unavoidable cost. That essentially the campuses were never made aware or provided any information. The money came off the top, and nobody worried about energy conservation on this campus. That is up until about a year and a half ago. You see the last point, because of the way it was managed fiscally, there was truly no historical incentive to conserve. We tried to get an energy conservation program started, kind of an embryo program in the mid-90s, and at the time I was the director of facilities. I got about a year and a half into that with some money that I had solicited from the provost and from UA and other monies, and we were trying to put together what I call a plowback scenario, and that is that we would invest in energy conservation projects. We had lots of them, most of them with paybacks under 5 years. We would meter very carefully the buildings in which we made those changes, and then all I asked was that university administration give us the metered savings the following year so we could put that into more energy savings. So, you can see if you follow that, you'll at a net zero cost, on a net zero cost basis, you should be able to drive your energy costs down over time. And the answer I got was, and I remember word for word at the time, was, no, we have better things to do with our money. And so they would not agree to fund the actual savings. And at that point in time, the campus said, why would we spend money on something if there's no return? If UA won't agree to provide those dollars to us, the savings, then there's no sense in it, which was absolutely true. So after about a year and a half, the program ended and we were done. So in mid-2006, all of a sudden, UA began to indicate there's a problem. We have an accumulated deficit. The first number that was out was about 60 million. Nobody was clear whether that was system-wide or just this campus. Well, as things unfolded and they actually got, and you've probably seen in the newspaper in the last 3-4 months, once the audit was done, the system-wide deficit was $117 million. So it's huge. At that point in time, all of a sudden, people got interested in energy issues, and maybe we ought to start conserving since we were rapidly headed to the poorhouse. The president put together a university energy task force that's got folks from all 3 campuses. Linda Katady, provost, assembled a campus energy conservation committee, gave us a charge of putting together an energy policy. Put an energy policy together, something that would provide rules of the road for the campus and the facilities folks. Not a plan, but essentially a more overarching policy. We did that. At that point in time, because of these annual deficits, Obviously, the bucket of money wasn't full enough, so they began to tax academic and operating units on the campus to the tune of somewhere in the range of $5 to $7 million a year to try to make the bucket fuller, the bucket out of which the energy was paid. Turns out that bucket's still not full, so they're still trying to get enough money in there to pay the bill. And as you all know, the bill's going up faster all the time. So let me talk a little bit about what's our energy use profile. How do we compare with our peers? I've got one chart on that, and I'm going to have it updated soon. And then what have we been doing? Here's the ugly numbers. The budget in '03 was somewhere about $25+ million. And the budget didn't get a lot bigger than that. And so you could see from '03 to '06, in those 3 years, the difference between the actual final cost that you see there and the budget of about $25 million is what led to that accumulated deficit. That's where the money came from. The deficit for this campus, our share, so to speak, of the $117 million is about $80 million. Last year, some of the fuel costs softened a bit, and it dipped to just under $60 million. I just got an email Saturday that the UA folks that have the utility dollars have now indicated over the weekend that it looks like it's going to be higher than 70 this year, and they're talking about a $12 million deficit for this year also. So clearly we have a long way to go in terms of getting our appetite matched to what our budget is. Looking at the campus, everybody thinks about the electricity issue, and because that's one of our primary energy sources. But just so you don't forget about that in terms on a pure BTU basis, this campus, almost 2/3 of the energy is actually in the form of steam that's delivered for heat and hot water, and we air condition with steam also. So when you think about campus energy, steam is a big item. Huge savings on that side also. Here's the electricity use in our buildings. We believe that these are estimates as best we can. About 60% of the campus electricity is going into motor loads. That would be air conditioning compressors, air handlers, HVAC systems, and that sort of pumps, etc. About 15% lighting, and then the other 25% is what we call plug load. And that's computers and printers and peripherals and all that stuff. How do we compare to our peers? Here's this is 2005 electricity consumption numbers from the Big Ten. I just got 2007 data a week ago, but there's some funny looking numbers, and I'm sorting out with some of the schools, making sure that they really meant what they said. Anyway, you can see here that in terms of, this is kilowatt hours per gross square foot. So we're normalizing to building area on the campuses. We're the second highest. Only Ohio State is higher than we are. Ohio State is still higher than we are. Interestingly, the numbers I just got from Iowa for 2007 shows them at 26. And it's hard for me to imagine Iowa would go from 20 to 26 in 2 years. So that's some of the data I'm trying to get sorted out. But so not surprising in a campus where there's been no incentive to conserve and we have no culture of energy management or energy conservation, we're pretty darn inefficient compared to everybody else. This is what I call the dirty dozen. This is a list of 12 buildings that use the most energy on campus. As you can see, the predominant common feature there are fume hoods. Fume hoods, as many of you know, use an inordinate amount of energy. And RAL has 270 fume hoods in it, something like that. I mean, RAL is essentially a very big, sophisticated wind tunnel. We heat and air condition air, blow it in, and then the fume hoods all blow it outside. That's really what it does. I joke, I had a friend years ago that used to, when he'd see a really bad building, he'd say, that has the thermal efficiency of a tent. Well, quite honestly, if you look at a building that has a lot of fume hoods, and you look at the way we push air in, heat it all the way up, and then blow it out, it's way worse than a tent. You could probably heat a tent of comparable square footage for less than what it costs us, because at least you keep the air out. So, the only other buildings besides fume hoods that you see in here, Vet Med Teaching Hospital, of course, has massive exhaust fans. It's all about ventilation for the animals, 12 to 15 air changes an hour. So there's incredible volumes of makeup air and exhaust air in that building. The ones that don't have fume hoods are there by virtue of their size. Main library, there's another one in there. Cranner. Yeah, those are the two that are in there largely because of square footage. But you can see we got 12 buildings, and we've got almost a third of the campus energy consumption in 12 buildings. The bad news is, and I've got great news on Cranner, but that the buildings where you have lots of fume hoods and lots of research activity are the buildings where it's hardest to conserve energy without investing lots of money. And one of the things we don't have, since we're covering the deficit, is lots of money. Here's the 6 basic areas that we're trying. I'm not going to touch on the research piece, but I'll touch on the first ones. We put up a website in May of 2007, kind of a clearinghouse with some. We have not done a good job of keeping it updated, and we're now going to address that with a communication plan that we're going to put in place for the next 12 to 24 months. And part of that will be much more frequent updating of that website. Most of the information that's in there is accurate, but as you know, if you're not on top of the website, it doesn't take long, and things that were future tense in the website now become past tense, and there's little things, so we got to get after that. That's what the homepage looks like. Campus commitment, I mentioned the energy policy. We had that put together and turned into the campus administration in the spring of '07. Last summer, late July, early August, Richard endorsed it and sent it around to all the deans and department heads. And then most recently, in February of this year, Richard signed the President's Climate Commitment, which takes us in a whole new direction, albeit related, and that would be carbon footprint. Energy measurement, we've invested about $2 million. The first thing that I asked them, I said, there's no sense in trying to get into an energy management program if we can't measure what's going on and know where the energy's going. Otherwise, we won't know what we're doing. We won't know what's effective and what's not effective. Well, it was not an easy sell. Everybody thought the $2 million ought to go into immediate conservation items rather than monitoring and measuring. My comment was, so if you spend it on all those energy reduction measures, how will you know if you're achieving your investment if we don't have solid metering? Oh, okay. So all those meters are in now. The last ones were the chill water meters. We had to wait over the winter in order to cut into the chill water system. Those are all in. And so we've got good numbers now, and we know what we're doing. Shadow billing, once we got the meters in place and we started to get the readings, we now send an energy statement. Some call it shadow bills. You can call it an energy statement, but it's the precursor to actually beginning to bill colleges and departments for their energy use. And so we send those out on a quarterly basis right now. Eventually, we'll get to monthly. So far, we haven't. The process is so laborious and so difficult in terms of all the things we have to look at to make fair bills. The problem is that most of our buildings are shared. If you have buildings that are assigned to one college in its entirety, it's very easy because that's how our metering is set up. But as soon as you're in a shared building, you have to have some ways of apportioning the energy, and that takes a great deal of work and calculation, as it turns out. We put together a retro commissioning team. These are, we handpicked some of our very best people. There's a temperature control technician, a digital controls electrician, building automation specialist, an engineer that leads the team, a air balance specialist, who's actually a sheet metal mechanic by trade, but an excellent air balance man. They go into a building. The whole process of retro-commissioning is going in and doing, it's more than fine-tuning. It's essentially looking at all of the HVAC systems, and in some cases other energy-consuming systems, to see, are they working in the manner they were intended? What do they look like? How are they operating? Over the years, controls have been altered, control points readjusted. Things, in many cases, you'll see, I'll show you some pictures in a minute, things get very inefficient in 20, 30, 40 years of a building's age, particularly in a building that in a campus that tends to underfund maintenance like this one does. And you'll see some of the results of that. So, bullet point 4 there, I said notable synergy with deferred maintenance effort. As many of you know, we have a deferred maintenance backlog of something in the range of $500 million on the campus. Well, a huge portion of that deferred maintenance bears directly on our energy consumption. So, it shouldn't come as a shock when you've got $500 million of backlog deferred maintenance that you could spend a lot of money and not only correct that, but also improve your energy situation. They were in National Soybean was the first building we went in. We're seeing about a 20% savings in that building. They spent 6-7 weeks going through that building, top to bottom, all through the systems. They then went to Krannert. Krannert, it looks like we're headed toward 30%. I've got some. This is a picture of the inside of the duct in Krannert. That's a return duct. And that thing you see on the end that's all encrusted with dirt and debris is what's called an air valve. They're pretty rare. You don't find them much. It was, essentially, it's a whole bunch of little piano hinge devices that were manually set. And what it did, it restricted air movement between one part of the building and another. And there's reasons why they wanted to do that, but to our knowledge, it's the only building on campus that was put in with these air valves. That air valve was put in a location where it was not only not reachable, you couldn't even see it. In order to get this picture, we had to cut a hole in a plaster wall, and we had to cut a hole in the duct, and then put a camera in and take that picture. So what you're seeing here is 40 years of accumulated dirt and debris. Needless to say, a system like that not only doesn't move air very well or very efficiently, but you've also got the issue of dirt and dust and everything else, which explains why in many areas of Krannert they were taping filter media to the diffusers when they came in. So, this is the kind of thing that you can find if you go to the extent of retro-commissioning. If you're just doing traditional maintenance, you don't see this stuff. I mean, as I said, we had to cut holes in walls in order to find it. That's a close-up view of what that air valve looked like. So, 40 years, you get a lot of dirt, don't you? I've got another one at the end I'll show you that we just took last week in another building. This is an outdoor air damper that goes to the choral rehearsal hall in Krannert. As you might imagine, that damper didn't work very well. So that damper is supposed to modulate under selected conditions to vary the amount of fresh air that go to that. And this damper was completely broken. So these are the kind of things we have to find and replace and repair. This is the before picture in Krannert. If I take the utility usage in fiscal year 07 and I apply the utility rates that we're using this year, we were headed toward, Krannert was headed toward an annual bill of somewhere around $1.3 million. Or as I like to tell folks, feeding a hog at $3,500 a day. We finished the retro commissioning in just before the holidays, and they were able to make a lot of adjustments before they left the building. These are the actual numbers from the electric meters, and what you see is we're saving about 25% a month on the electric bill, which will carry out to about $75,000 a year. on just the electric side. I haven't had a chance to update these, but this were the numbers after 2 months. So you see that we're at, call it 40% reduction on the steam consumption and about an 80% reduction on show water for just those 2 months. So right now we're well on the way to reducing the energy bill at Crandard by $300,000 to $400,000 a year. But it took a team of 4 or 5 people spending 2 months going through that building and finding all those ugly things like you saw up there. Performance contracting. So we only have one retro commissioning team, and they're only going to be able to do 6 to 8 buildings a year, and we have a lot of buildings on this campus. So that won't get us there fast enough. What can we do to pick up the pace? We can go to outside contractors called ESCOs, energy service companies. ESCOs will come in. That's what they do, is energy reduction. They can fund the project up front, and then they guarantee that your savings will be greater than whatever annual payment you make them. This work is enabled by specific state legislation, and the only requirement is that we have to keep the payback. Payback has to be under 20 years. So we can bring in, by bringing ESCOs on board, we can have, we could have 5 Tesco contractors doing multiple buildings on this campus simultaneously, so that we can pick up the pace from what we can do with our own folks. The energy, I talked about the energy incentives. I've got a copy. I was trying to get a PDF copy that I could put on a slide, and I wasn't able to get that done this morning, but I've got a copy of what the energy bills look like that we send to the colleges. College of Engineering bill for the month of December was $771,000. So we are getting some attention on the academic side now with by sending those bills out. State grants we applied for about a year and a half and got 2 grants from the Illinois Clean Energy Foundation. One for lighting upgrades. That's essentially replacing T12s with T8s and solid state ballasts. And then another research project, actually, to do a small combined heat and electricity plant from that would be fired by Miscanthus, and to be somewhere at the Vet Med complex. Climate initiatives, I said we documented our climate footprint. I mentioned that Richard had signed the President's climate commitment. Here's the brief version of our footprint. This is pretty interesting stuff, because you can see very quickly those first 4 lines is what's happening at Abbott, and you've got better than 75% of our campus energy footprint. Then you look at the electricity that we buy from the Midwest grid, called MISO, and there's another 18%. So you've essentially got, call it 95% of the campus carbon footprint is really involved in what goes on at Abbott, as opposed to all of the one where it says vehicular emissions. That is all of the fuel that was burned or purchased by the campus carpool. So that includes when people take carpool cars on trips and they go to a gas station in Columbus, Ohio, and put gas. All of that is collected. So that's all UIUC vehicles. And that number only amounts to 1% of the carbon footprint. So over the next 2 years, the President's climate commitment says we will put together a plan on how this campus will achieve climate neutrality. We get to set the date by which we do that. That's a good thing. But you can see that if we're going to get serious about it, our focus has to be, in general, on campus consumption and changing what happens at Abbott, because that's where really most of it is. Student involvement. There's probably some of you here that have had. Actually, you got a grant from two grants from the students. The students have kind of led the university all the way on this. They've been pushing and dragging the university into this brave new world of sustainability the whole way. The students are now collecting $7 a semester, which gives them about $600,000 a year that they're investing in grants and those sorts of things. With good leadership on that student committee, and they pay a great deal of attention to their change in leadership as students graduate and move on, and they do a very nice job. South Campus wind turbine, this was supposed to be 3 at one time. The price of wind turbines has doubled in the last 3 years. We can't afford 3 of them anymore. So President White made a decision in February that we're going to put in 1. The payback on this is lousy. The payback is about 18 years. But on the other hand, it's important from an instruction standpoint, from an image standpoint, potentially from research. It's a visible statement regarding our concern regarding energy. So for all those reasons, President White decided to fund it. But we have hundreds of projects with under 5-year paybacks, and so to fund this is a little painful, but I understand there's a bigger picture sometimes. Business instructional facility, this has gotten a lot of press. This will be occupied in the fall. It will be our first LEED certified building, and it is a LEED Gold building. That's very exciting. We have altered now the construction standards for UIUC. All future facilities will be LEED Silver or better. And that even applies to large-scale remodeling projects. We'll be doing the same thing there. So that pretty much runs through the picture. The good, the bad, and the ugly. With maybe heavy on the ugly. I wanted to show you one more. Speaking of ugly, this is not in Krannert. This is in another building, which shall remain nameless. This is looking down again, a duct. This duct was not as inaccessible as the one in Krannert, but still hard to get to. What you're seeing at the end, you see those lines across. Those are actually turning vanes. Sometimes when a duct makes a 90-degree bend, you put in little curved pieces of sheet metal in that corner. What that helps the air turn that corner, called turning vanes. In this particular case, the turning vanes are completely plastered with something on the front side. It's really made it more of an air filter than it has. But this is a building that was built in 1964. It's had huge quantities of air running through it for 44 years. And so as we speak, there is a contractor over in that building cleaning these ducts. There's what it looks like close up in terms of what's accumulated at the bottom of that duct. But what that does, it just impedes airflow into the space, so that people don't get anywhere close to the air movement or the air transfer that was intended to come into the room, which causes them to mess with thermostats. So I mean, it just results in inefficiencies all the way through the system. But we're going to find lots of that as we go through the rest of the buildings. 31 buildings actually will get us about 60 to 65% of the campus energy consumption. And if I go to 80 buildings, I get 90%. So if you look at the so-called building list, this campus says there's 175 major buildings. Well, we only have to get after 80 of them to get 90% of the energy use. So that is the good news. It's remember the Pareto principle. Anybody remember who Pareto is, or was, I should say? He was an Italian mathematician in the 1500s who noticed this relationship that in many cases 80% of the benefit came from 20% of the issues. So, pretty smart guy. Here we are 400, 500 years later, and the Pareto principle still applies. With that, I'm open for Q&A. Yes?
You showed a comparison of Big Ten campuses. Michigan State was about half as much use as the others. Have they had an energy policy longer, or what are they doing there to answer energy?
Yes. I spent the first 16 years of my career at Michigan State, so I'm very familiar with it up there. Yeah, energy conservation was even prior to the oil embargo of '73, when the whole nation got concerned. The history there was one of really a first cost issue. They didn't want to build power plants any bigger than they had to. And they realized many, many years ago the way to do that was to make all your systems as energy efficient as you could. Well, that whole philosophy picked up pace in the 70s, and they've never lost that focus. And so what you see is, on a per square foot basis, Michigan State uses half of what Ohio State uses. I mean, those numbers are just eye-watering. Yeah, you go, half. How is that possible? It came from lots of constant attention in every way over 30, 40 years. So, that's the other side of the coin. If you keep your eye on that, and that's a priority, that's what you can do. We're at the other end of the scale when you don't watch it. Yes?
Yeah, you said wind turbines have a long payback. Could you describe the 2 or 3 actions that have the shortest payback?
The shortest paybacks for us right now are control replacements. The majority of our buildings still have pneumatic controls. And the pneumatic controls, moved to, today, we put in what are called direct digital controls, which are all electronic based. With DEC, we can do all kinds of fancy, clever things and vary system operating temperatures and use this condition to change set points on this. There's all manner of interactive protocols that we could use with DEC that were not practical or possible with pneumatic. So, and those pneumatic controls, many of them are old enough, they don't work very well. That's what a lot of the time of our retro commissioning team is spent looking at controls. And so the best way, now because of limited dollars, we're going in and we're replacing pneumatic thermostats, because the cost of going in and completely scrapping out all the pneumatics and putting in DEC is huge. Nevertheless, the payback is dang impressive. What's happening, we're doing the control replacements and the upgraded DEC coupled with the deferred maintenance program. So we have about 50 to 60% of the deferred maintenance backlog, that $500 million I talked about, is actually in HVAC related stuff. And a lot of those things are like replace air handlers, replace air conditioning units because they're old and inefficient. At the same time we replace that air handler, we replace all the controls with direct digital stuff. So that's really the best. But the other thing, the other area is outdoor air. The 20% savings we're getting in National Soybean Lab, that's coming. We found 2 huge outdoor air dampers. And the way those normally work is if it's 55 degrees outside, they go full open so that the building can take advantage of that cool air. But as it gets colder outside, those outside air dampers are supposed to modulate closed and to a minimum position. We found 2 huge outdoor air dampers in Soybean Lab that were frozen, wide open. Absolutely. So I have no idea how many years that they've been in that mode, but that means in the summertime, you're air conditioning and bringing the moisture out of all that outdoor air, and in the wintertime, you're heating it all the way up. And so that's where the majority of that 20% came from, essentially, in those 2 items.
So HVAC,
Oh, yeah, there's no question.
More so the lighting.
The lighting is, in some buildings, lighting has a wonderful payback for us. Right now, in the buildings where we have, that's going to be funded with that grant from the Clean Energy Foundation, funds us 60 cents per watt, I think is the number. It turns out to be about almost half of what we have to spend to do the lighting upgrade. Well, if you look at then the payback we get on our share of that money, it's 2.8 years. So again, that looks really good. But if you look at how much energy do you save in the total building by doing the lighting upgrade, I mean, it's not chicken feed, but it's nowhere near what you save if you find outside air dampers that are frozen over. So paybacks are good, but the grand total is, it's important for us to get after that piece, but it's not going to get us to where we need to get to. Yes?
Will the new controls allow individual buildings to respond to outside air temperature and internal conditions? It's been a standard joke on campus for 30 years. I've been here that sometime in the spring they throw a switch and all the buildings warm up, and sometime in the fall they throw a switch and something else happens, and that's why everybody wants windows that open, because the buildings seem to all be controlled what's right around it. So my basic question is, will these new controls allow some individual buildings to be more flexible and responsive to their own situation?
In some cases. Let me give you an example where it won't help us. Davenport Hall. Davenport Hall, I get more overheating complaints from Davenport Hall than any building on campus. Why? It's got radiators. There's not even thermostats that control the radiators. Essentially, so as you say, in the fall, they turn the big steam valve, steam goes on, radiators come on, and some of the spaces overheat to 80 degrees. Well, over the years, of course, since the building does not have central air conditioning, we have taken the only operable window in many of those offices and we've put a window air conditioner in it. So now when the space goes to 80 degrees, the only way those poor people have of keeping that space so that it's habitable is to turn on the window air conditioner in February or December. So in that particular case, it goes way beyond controls, and it goes to the basic heating system that's in the building. And what we have to do are retrofit individual radiator valves in every, well, if you've ever done work in an old house or an old building, as soon as you try to take that piping apart that feeds the radiator to put that valve in there, the piping crumbles. And now you start going back until you get the pipe that won't crumble, and the project becomes hugely expensive and hugely time consuming. So that's the ugly side of this, where we know we have needs and yet we're kind of doing this for now.
And the other question I had, you said that new construction is going to have to meet the LEED standards. Does that include having somebody watch over the architects? So instead of being architecturally grandiose, being practical? I'm thinking of some of the new buildings like the Ag Library, which the first floor is basically a wind tunnel in the winter. Somebody's coming in one door or the other. The wind blows through, the receptionists refuse to serve on the first floor,
Right.
things like that. And in any number of new buildings, they're beautiful, but dysfunctional in many ways. Is that part of the lease? Is to have somebody look at it from a practical point of view, how doors open?
We have fought battles with architects for years and typically lost because there was never any kind of overarching standard or something that FNS engineers could point to when you're arguing with an architect who's trying to build a monument to himself. Now that the campus has in fact officially adopted LEED standards, it makes that task much easier. And quite frankly, you can have architecturally spectacular buildings and have them efficient from an energy standpoint. An example, I think, will be BIF. That's going to be a pretty striking building in terms of our typical campus architecture, and it is LEED Gold. Now, the numbers that we got from the engineers on that building, I don't believe. Our average building on this campus uses about 270,000 BTUs per square foot per year. A typical residence hall uses 150 to 190,000 BTUs per square foot per year. The engineers on BIF said it's going to use 33,000. And I told them, I said, I'll believe that when I see it. There's no question it will be very efficient. It will use way less than our standard building or conventional building. But do I think we're going to see 33,000? No, I don't think so. But if it's at 60, it's at a fourth of what the campus average is. So, that's all good news. Yes?
Just with regard to the question about architects, just given how many architects are directly involved in the U.S. Green Building Council, I mean, isn't it possible just to find people who are architects who are that committed to the LEED standards and work with them, or?
Yes and no. In cases where we have a choice, we might be able to do that. But when you take a building like Siebel, the architect was picked by the donor. When you take a building like BIF, the architect was picked because of his reputation as a New York architect and the fact that he has some affiliation with the U of I. So there's particularly on big projects, there's a lot of politics that goes into architect selection. But again, regardless of who we pick now, we have a very clear statement. Our buildings will be LEED Silver or better. And so that's an advantage. I mean, that's quite frankly, we're only offered that advantage because there are such a thing as LEED standards. 20 years ago, we didn't have them.
Has anybody considered changing some of the rules under which the contractors have to operate? I'm specifically thinking of, I may be wrong on my time since that's not my area, but a new building is built, there's essentially what we would commonly call a warranty period of like a year. 1 year. A year is not enough time for some of the systems you're talking about, and like I'm aware of a new building on campus, they found out that the wiring wasn't put in right. So they can't turn certain lights on and off. Little things like that. They're on an automatic system that you can't mess with. And it would seem to me it'd be a good idea if it's within the campus's ability to change that rule on certain types of systems so you go back and have the builder or the architect or somebody come back and fix a problem that's simply not going to be visible for a year or two.
We've had that discussion in years past. As you know, that's not a new problem. The difficulty is that when you talk to the contractors about it, they're going to price that in. If you put in the documents, it's going to be a 2-year warranty. You're going to pay for that, one way or another. And they're going to have to guesstimate how much time that they're going to have to come back and spend in that building for a 2-year period rather than a 1-year period.
It'll be performance-based. So like with this building I'm thinking of, after a year and a half, they found out the doors, the outside doors, were basically hollow core doors designed for the interior. They put the wrong doors on, but nobody knew it until something happened.
Yeah, and in that particular case, it doesn't. If we have a competent commissioning process at the beginning, and we have competent construction inspectors, it doesn't take 2 years to find out you have hollow core doors. So that's not something that the 2 years is going to do. There's a better way to solve that problem than to have go to a 2-year warranty, is my point. Yes?
What kind of, have you looked at any of the data centers on campus as far as power and food?
Just start to look at those now. I've met with there's a group of campus IT managers, and I've met with them, with all of them once. Boy, I was like the bubonic plague to them. They do not want to talk or hear about energy conservation. And as one of them put it to me after the meeting, he said, you got to understand something. Success in our job is based on making sure that all of the computers are up and operating 24 hours a day for anybody that wants them. Success in our job has nothing to do with conserving energy. That's your job. And I thought, well, he has a point. And I hadn't really thought about it that way before. But there's about a handful of them who are getting into the green movement in IT. and they're sort of leading the way. And in fact, we're having, they just set up a panel discussion for the end of this month, and I'm one of 4, and it's going to be all about the greening the IT business and all of the IT managers. So we're getting there. But all I wanted them to do, and all I asked them to do, was to administer their systems such that people can shut their computers off at night and don't let them run 24 hours a day. Oh my heavens! You can't imagine the pushback I get on that. It's just huge.
I know I have some very low equipment, and I never see a power cool. Yet I know somebody somewhere in UA is paying for it.
Right.
So
Exactly.
Where do I find out if there's no policy where if you reduce your power and cooling, this happens?
Yeah. Gary and I talked about that, and I haven't, somewhere in buildings like this, because this is sort of a different critter, because you're not fed from Abbott, you're fed directly from IP. So this building falls into what the UA utility people call the small bills. Well, we never see the small bills. And somebody has to sort those out by building number or something else in order for us to see them. And I've had a hard time even getting the aggregate data out of UA, let alone to press them for the details of the small bill. So I haven't pulled that off. We're headed there, but I don't have that data at this point in time.
And then my follow-up question is, who sees the shadow bill?
I'm sorry.
Who sees the shadow bill? Is it one person at their knowledge, or is it?
Well, you know, it's
anybody see it?
That's a very good question. I made the presumption that if we sent a $700,000 bill for 1 month to the Dean of Engineering, that he'd make copies and share them with the department heads. And I'm getting the impression, I'm not picking on engineering, but I've had discussions with department heads and other faculty who have not heard one word about this. So in some cases, this is just not going past the dean. So that's why we're now, I mentioned quickly, we're putting together a 12 to 24 month communication plan, and we've got to get better penetration, because we're simply, even though we've been sending out these bills, and they're very detailed. I mean, they show by building and square footage and percent and everything else, but the deans are not passing them along, which amazes me. Because if I were a dean, the first thing I'd want to do is make all my department heads know about that. And it's not happening in all cases. Yes, sir.
I know that the Blue Waters Computer Center, a couple blocks away, is going to...
You're a new neighbor? You're a new neighbor?
Yeah. Oh, no, I'm not a new neighbor. No, I will be in your building, but that's going to have a significant increase in energy consumption. Is there a work towards reducing that?
Yeah. Yeah, boy, you talk about a showstopper. The Blue Waters project will increase that number it actually is going to get way worse, because it's a very small building with an inordinate energy consumption. Our maximum campus demand in the summertime, this last summer was 78 megawatts. We probably run 60 megawatts most of the year. It never drops below 41. If you pick Christmas night at 2 a.m., because I went back and looked at it, this campus was using 41 megawatts of power. Now, boggles my mind to figure out where that's going at that point in time. But what it says is to how much stuff is running that need to be, right? But in any event, Blue Waters is the system has a capacity of 25 megawatts, or a third of our summer peak. And they're telling us that from a consumption standpoint, we should plan on it for 20 megawatts 24/7. Well, if you take 20 megawatts 24/7, that's 30% of our energy consumption for the entire campus right now. So the whole thing notches up 30%. Most of that is cooling. Most of that's not in the computers. It's in cooling all that stuff. So what we're in the middle of designing right now, actually not in the middle, we're at the leading edge of the design, but will be a huge chill water storage facility we will either take those 2 million gallon oil storage tanks and convert them to chilled water storage, or we will build new chilled water storage. But the idea is when utility rates and costs are the lowest in the middle of the night, to essentially charge that full of chilled water, and then during the peak of the day, we'll use the stored chilled water to cool that system. But it's going to be real hard to not have that building increase the overall campus energy consumption at least 20%.
See, the chilled water seems like it would mostly decrease the cost of the energy, not necessarily
the amount of the energy. It's absolutely correct. You're absolutely correct. I agree with that.
Are we looking into also ways where we can actually reduce the energy consumption of the facility?
Yeah, we've got 2 engineers that are working on that. The difficulty, there's not a lot of magic. When you've got that much expensive computer gear rejecting that much heat, we're pretty much based to something that looks like vapor compression refrigeration. Now, you can twist that several different ways, and you can go with variable volume pumping and all those other kinds of things. But using today's technology, we've got to remove that heat, and we're only going to get it down so far. I thought, of course, that the big grant we all heard about from Blue Waters was going to pay the utility bill. Not so. Turns out 90% of the grant that you all read about went to IBM direct. That's for the technology side. And we're left holding the bag for the rest of it, including how to deal with how to come up with the energy to cool that place. So we have 2 people that are focused at least half time on nothing but that very issue right now. Yes.
I'm curious, has there been any talk about when new buildings and projects are sponsored, doing something like saying, you know what, a certain chunk of this money has to be set aside for dealing with energy costs or money?
Thank you. I co-authored a book on that just 2 years ago, and it's what we call total cost of ownership. You can look over history. It doesn't make any difference whether it's today or 50 years ago. You look at the total cost of owning a building over its lifetime, about 1/3 or less is involved in building it. 2/3 is in the care and feeding of that building. It's energy, it's maintenance, it's custodial, it's periodic replacement and upgrade, et cetera, et cetera. Anyway, thank heavens, the provost that we have now has absolutely bought into the concept of total cost of ownership. And she's saying that from now on, as far as the capital review process, a project will not be approved unless the total cost of ownership has been identified and there is a clear plan on how that total cost of ownership will be met. So that's the first time I've been trying to get somebody at the top end to embrace that idea for a long, long time. This is the first time I've had somebody do it. Unfortunately, it took us $117 million in the hole before people got really serious and interested about it, but that's where they are.
Chair, I have a question about the University President's climate change commitment. Yeah. Did you say that we're committed eventually to become a carbon neutral campus?
That's right. The primary requirement of the President's climate commitment is, there's some small stuff that says you got to do some of these things. Well, we've already done those. But the real big deal is that within 2 years from the date that you sign, you have to have a plan that says how you will be a carbon neutral campus and by what date that will happen.
So, I mean, this looks hard enough just to get us even on our energy budget, much less becoming carbon neutral. I mean, how are you going to create that plan in 2 years? Who's working on it?
The group to put together that plan hasn't been assembled yet. I know 2 months have gone by already. 1/12 of our time to develop the plan has gone by, and we haven't even identified who the group is.
Well, I'm not going to volunteer. Who that's a job?
We may draft you. Yes.
Why is it in the wintertime the campus building is always so hot? I mean, isn't that waste of energy?
It is absolutely.
Yeah,
waste of
then
energy.
how come we avoid that?
And a lot of that has come from, since there wasn't any energy driver on the maintenance side, there was nothing that told the temperature control technicians and the people that actually have to answer the people in the building who complain. There was nothing that caused them to reduce temp. If anything, the majority of the complaints in the wintertime are it's too cold in here. And so over the years, over 30 years, the name of the game has been adjusted in whatever load it takes so that people don't complain without any concern for the energy consumption therein. So that's how we got here, and that's why. Now, in the case of the Davenport Hall, like I talked about before, that's a system that simply doesn't have the controls that let us keep it down. We have many other buildings where over the years, all those systems have been turned up so that anybody who was previously complaining about it being cold no longer complains. One of the things the retro commissioning team does is go back in and turn all those systems back down to the adjustments or the set points that they were originally intended. So we're hoping to get after that. Yes.
Have you done a survey or anything to figure out how much of your plug-in cost is due to people bringing personal space heaters sitting under their desks or fans? I've seen dueling windows where one office has a window open in the winter because the Canadian person in the next room running a heater.
Yeah, I don't quantify that number, but it's significant. Every building we go in for retro commissioning has space heaters. Every building. We just finished Newmark Lab, and our guys are guessing they saw at least 70 to 100 space heaters in that building. And so, there's lots of it out there. And then, and of course, how do you deal with that compared to your observation that we have so many buildings where it's too warm? Well, part of this is a building that is perfectly managed from an environmental standpoint. If you look at all of the design data, 70% of the occupants deem it as comfortable. That's the best you can do. So in any building, even with perfect HVAC, 30% of the occupants are going to find it either too warm or too cold. And what's happened here, absent a policy and absent concern over this, it was the squeaky wheel gets the grease, or the heat, as the case may be. And it was adjusted, whatever it took. Even if there was only 3 people in the building that were squawking, if they squawked often enough and loud enough, we adjusted the system so that they wouldn't complain. And you can't do that if you're going to hold down energy.